This set of notes explores custom sorting of lists. The topics covered include deep copying a list of strings, sorting a list of strings by default, custom sorting by providing a key function. We will examine writing our own reusable functions for sorting and using a lambda function, which is a once-and-done method of sorting. First, let's consider a deep copy a list. Python provides a copy called a shallow copy. This is the ordinary way that Python will copy a list. Under these circumstances, we will have two names, but just one set of the list data structure. There's a dependency here. If we alter one of the lists, it will automatically alter both. This is Python's default way of copying. In order to do a deep copy, where we have two names with two separate but identical lists, we must use the import copy and do a deep copy function. These will produce independent lists. Changing one will not alter the other. Let's look at some code. Here is sample code for a shallow copy of a list. We are using the Chapter 4, Section 2, Example 6 code. List 1 consists of 6 words: democratic, sequoia, equals, burr, break, and 2. We create another list named shallow by copying list 1. Then we print list 1 and the copy of list 1 named shallow. Then we append the word ice cream to shallow and print list 1. Here is the sample output. We see list 1 and the copy of list 1 that we called shallow. After appending ice cream to shallow, we then print list 1. And notice that although we didn't make a change officially or formally to list 1, it has been changed through the name shallow. So these two lists are absolutely not independent of one another. Changing one will affect the other. This is what's known as an alias. Here is sample code for a deep copy of the list. We will also examine the default method of sorting a list of words or strings. First thing we need to do is import copy standard library code. We see list 1 is still democratic, sequoia, equals, burr, break, and 2. We print that list. And then we create list 2 by using the imported copy, deep copy function of list 1. This will build an independent, separate copy named list 2. We sort list 2. The default method of sorting a list of characters in words will be using an alphabetic approach. Then we print the sorted copy of list 1 named list 2, and then we print list 1. And notice that although list 2 is sorted in alphabetical order, list 1 remains unchanged. The next topic to explore is sorting using a key. In this case, we're going to look at 3 different ways we might be interested in sorting that list of words. The first sort uses a key based on the length of each word element. Looking at these words, we can see that the shortest word is 2 and the longest word is democratic. So when the sort is completed, 2 should be first, followed by burr, then break, equals, sequoia, and democratic will be last. Next, we sort the list using the key last character. Last character is a function that we write, and we see that the last character function accepts as a value each element of the list, one after the other, to do the sorting routine. What we will be sorting on here, though, is not the alphabetic listing of these words, but instead we'll be returning the last character in each one of those words. So it will be the last character of each word that determines its order in the sorted list. Looking at the list, we see that Sequoia ends with an A, so that should be first in our sort. Democratic ends with C, that should come second. Break ends with a K, it should show up third, followed by the word to, burr, and equals. Finally, our third sorting mechanism uses number of vowels with reverse set to true. All the other sorts did not have reverse set to true, so the sorting was done in ascending order, from smallest to greatest. In this example, number of vowels, we are counting the vowels in the word elements, and whichever word has the most vowels, because we have reverse set to true, should show up first. Let's look at that number of vowel function. We see we have a tuple named vowels, consisting of A, E, I, O, and U. We have an integer total set to 0. And then for vowel, in vowels, we are going to check to see if it's in the word, we will count it and add that to total. So for every vowel, A, E, I, O, or U, that exists in the word, first democratic, then Sequoia, then equals, burr, break, and to, we will sort that list of words based on whichever one has the greatest number of vowels, down to whichever word has the least number of vowels. Looking at our list, we see that Sequoia has 5 vowels, so that should come first. Democratic has 4 vowels and should be second. Equals has 3 vowels, so that should come third, followed by break with 2 vowels, the word to with 1 vowel, and burr, which has no vowels. Here is the sample output from running this code. Sorted by word length, in ascending order, we see the word to, because it had 3 characters, followed by burr with 4, break with 5 characters, equals with 6 characters, Sequoia with 7 characters, and finally democratic with 8 characters. Our second sort, based on last character, which looked at the last character in each one of these word elements, returned Sequoia, ending in A, followed by democratic, ending in C, break, ending in K, to, ending in O, burr, ending in R, and lastly, equals, ending in S. Our third sort, based on the number of vowels, from greatest to least, Sequoia, democratic, equals, break, to, and burr, which had no vowels, comes last. The last example replaces the last character function with a lambda function for the key. Everything else in this code is the same, but we see list1.sort, key set to lambda. We need to use that keyword. The word here is just a placeholder for each element of list 1. So while it's sorting, it will replace word with each one of those elements, and it will look at the last character of that element to do the sorting. As we saw in the previous slide, Sequoia should come first in this example, followed by Democratic. Let's run the code, sample, and sure enough, we see using the lambda function, Sequoia, Democratic, break, to, burr, and equals. So when should we be using lambda expressions or functions? If this will be a once and done situation, where we just need to get something done on the fly quickly, we don't need to save a copy of that function because we're not planning on reusing it for anything, then a lambda function here is appropriate. It will only work with something very simple. We could not replace the number of vowels function with a lambda. But if it's a simple expression, for instance, the last letter of the word, as we see here, then the lambda works just fine. Another time we might be using lambda is if our element consisted of a tuple, and perhaps one time we're sorting based on the second element inside the tuple of our list elements. We could simply use a lambda to identify, use the second element within that tuple for each list element. Your book shows some examples of this, and you can review it in your text. Recapping, we took a look at deep copying a list of strings. Remember that when we just assign one list to another, we now have two names for the same data structured list. If you need to have a separate independent copy, you will need to use the deep copy function from the copy library. We looked at sorting a list of strings by default and by providing a key function, and we looked at how a lambda function can replace a separate key function for sorting. Here are some suggested follow-up exploration for you. Do type in the code or download it and explore a little bit. Try sorting with numbers. Try sorting mixed case words. Try sorting with lists that contain words and numbers. Try writing your own lambda functions and sorting on a list of tuples. Post any and all issues or discoveries to this week's open discussion forum. Note that the list data structure is mutable, and so it's not unusual that we would copy data from a tuple into a list and do some type of sorting on it. We see this interchange in this week's topics and sample programs between using tuples, lists, and dictionaries. As always, happy Python coding!